In this video, I am going to explain regarding Floyd-Warshall algorithm. This algorithm is used to find shortest path between all pairs of vertices in a directed as well as undirected graph. Floyd-Warshall algorithm uses dynamic programming approach to solve the problem. Dynamic programming approach is a technique where a complex problem can be solved by dividing it into number of subproblems. Now let us understand this algorithm using an example. Here in this example, I am having 4 vertices 1, 2, 3 and 4 and their corresponding edges. Each wedge is having their corresponding weights. This algorithm uses adjacency matrix to represent distance between any pair of vertices in the graph. Now let us calculate the initial adjacency matrix A0 for this given graph. So in this adjacency matrix A0, if we see 1, 1 will represent the distance from 1 to 1. 1, 2 will represent the direct distance from 1 to 2. So here I am not including any intermediate vertices. In subsequent adjacent matrices, I am going to use that approach. But for now, in the initial adjacency matrix, I am going to represent only direct path between two vertices. If there is a direct path, I am going to write that corresponding weight of that path. Otherwise, I am going to indicate it as infinity. So now let us see the distance from any vertex to that vertex is anyways zeros. So I am marking distance from 1 to 1 as 0. Next, the distance from 1 to 2, right? So if you see the graph, the distance from 1 to 2 is 3. 1 to 2 is 3, right? So I am going to mark 1 to 2 distance as 3. And then 1 to 3, if you see, there is no direct path from 1 to 3. There is a path from 3 to 1, but there is no direct path from 1 to 3. So I am going to mark 1 to 3 as infinity. As I have told, if there is a direct path, I am going to represent its weight. Otherwise, I am going to represent it as infinity. Next, the distance from 1 to 4 is 7. Distance from 2 to 1 is 8. 2 to 2 is anyways 0. 2 to 3 will be 2. 2 to 4, if you see, there is no direct path from 2 to 4. So I am going to represent it as infinity. Next, 3 to 1. Distance from 3 to 1 is 5. 3 to 2, there is no direct path. So I am going to indicate it as infinity. 3 to 3 anyway is 0. 3 to 4, distance is 1. 4 to 1, there is no 4 to 1, there is a path. 4 to 1 it is 2. 4 to 2, there is no direct path. I am going to indicate it as infinity. And then 4 to 3, if you see, there is no direct path. 3 to 4 we are having, but 4 to 3 we don't have. 4 to 4 anyway zeros. This is my initial adjacency matrix. Next, we have to calculate A1, which represents the shortest path from any pair of vertices through vertex 1. Like that, I have to calculate A2 will represent the shortest path between any two pair of vertices through vertex 2. And then A3 will represent the adjacency matrix, which represent the shortest path between two vertices through vertex 3. Finally, A4 is our result, which will represent the shortest path between all pairs of vertices in the given graph. Now let us calculate A1. As I have told, A1 will represent the distance from two vertices through vertex 1. So if you see here, anyways, the distance from a vertex to itself is anyways zeros. So 1 to 1 is 0, 2 to 2 is 0, 3 to 3 is 0, and then 4 to 4 is 0. I am marking it. Also, the distance from 1 to 2 will be same as A0 because already 1 is included in our vertex. So that's why I am marking, giving the same distance 0, 3 and 7. Why I am giving the same value? Because 1 is already included in the path. 1 to 2 means I am going through via 1 only. So there is no change. That's why I am writing the same values. Similarly, if you see this column also, 2, 1 also will be same because 1 is included in our path. Right? 2, 1 is what is 2, 1, 8, 3, 1 is 5, and then 4, 1 is 2. Remaining vertices we have to calculate. So I have to calculate A1 of 2, 3. A1 of 2, 3 will be minimum of A0 of 2, 3, as I have told, A1 of 2, 3 will represent the shortest path from 2 to 3 through 1, right? So it will be A0 of A1 of 2, 3 will be A0 of 2, 1 plus A0 of 1, 3. So basically I am going through 1. So I want to find A1 of 2, 3. So I am going A0 of 2, 1 plus A0 of 1, 3. So out of these two, whichever is the shortest, that will be the value of A1 of 2, 3. What is A0 of 2, 3? Direct distance from 2 to 3 is 2, right? Minimum of A0 of 2, 3 is 2. And this one, A0 of 2, 1 is 8 plus A0 of 1, 3 is infinity. So which is nothing but infinity. So minimum of 2, infinity will be anyways 2. So my A1 of 2, 3 is 2. Similarly, I have to calculate A1 of 2, 4. A1 of 2, 4 will be minimum of A0 of 2, 4, A0 of 2, 1 plus A0 of 1, 4. So basically I am checking if the distance is minimum without vertex 2, I am going to use that value only. If I get a minimum distance through vertex 2, I am going to use that minimum path distance. So let us see, minimum of A0 of 2, 4 is infinity, right? This is infinity. And then A0 of 2, 1 is A0 of 2, 1 is 8 plus A0 of 1, 4. A0 of 1, 4 is 7. A0 of 2, 1 is 8 and A0 of 1, 4 is 7. So here A1 of 2, 4 is 15. Next we will see A1 of 3, 2. A1 of 3, 2 will be minimum of A0 of 3, 2 is infinity, and then A0 of 3, 1 plus A0 of 1, 2. I have to find A0 of 3, 2 means through 1, right? 3, 1, 1, 2. 3, 1 is A0 of 3, 1 is 5, and then A0 of 1, 2 is 3. So I got value as 8. So out of infinity and 8, 8 is minimum. So I am going to update the distance from 3 to 2 via 1 is 8. So next 3 comma 4. Initial distance is 3 comma 4 is 1, right? So we have to do it through y. 3 comma 1 distance is a naught of 3 comma 1 is 5. Initial distance is 1. I am getting the first distance itself as 5. So anyway it is less, right? So I am going to give as 1. Next a1 of 4 comma 2. Again let us find a1 of 4 comma 2 will be minimum of a naught of 4 comma 2 comma a naught of 4 comma 1 plus a naught of a naught of 4 comma 1 plus a naught of 1 comma 2. So a naught of 4 comma 2 is right now it is infinity, and this one a naught of 4 comma 1 is 2, and then a naught of 1 comma 2 is 3. So I got value as 5. 5 is less than infinity, right? So I am going to mark it as 5. Next I have to calculate a1 of 4 comma 3, which is minimum of a naught of 4 comma 3 is infinity. Anyway it's infinity. Next one a naught of 4 comma 1. A naught of 4 comma 1 is 2 plus a naught of 1 comma 3. A naught of 1 comma 3 is infinity. So both I am getting as infinity. I am marking it as infinity. This is my A1 adjacency matrix. Now let us calculate the A2 adjacency matrix. So we have to follow the same process as A1. So A2 adjacency matrix will represent the distance from two pair of vertices through vertex 2. So anyways the diagonal elements will be 0, 1 comma 1 is 0, 2 comma 2 is 0, 3 comma 3 is 0, and then 4 comma 4 is 0. Similarly, since we are going through 2, right? So the 2 row and 2 column values will be same values. So it will be 8, 2 and 15. What is my second column? 3, 0, 8, 5. Remaining we have to calculate. So remaining A of 2 comma 3, right? Sorry, A of 1 comma 3, A2 of 1 comma 3. A2 of 1 comma 3 will be equal to minimum of A1 of 1 comma 3 comma A1 of 1 comma 2, so via vertex 2 plus A1 of 2 comma 3. A1 of 1 comma 2 is, if you see, 3 plus A1 of 2 comma 3 is A1 of 2 comma 3 is 2. So 3 plus 2 is 5. Initially what is A1 of 1 comma 3? It is infinity, right? So 5 is lesser, right? So I am going to mark it as 5. Similarly, we will calculate the remaining values. We get the A2 values like this. Next, we have to calculate A3 adjacency matrix, right? So here also for A3 will represent the distance between any pair of vertices in the given graph through vertex 3. So as usual, distance from 1 to 1 is anyway 0, 2 to 2 is 0, 3 to 3 is 0, 4 to 4 is 0. And since this 3 is included in our path, right? So the values corresponding to third row and third column will be same. So it will be 5 8 0 1, and similarly for this 3 it will be 5 2 0 7. We have to calculate the remaining ones. I will show you one value like that you can do for the remaining values. So I have to calculate the distance from 1 to 2 through 3, vertex 3, right? So basically a3 of 1 comma 2 will be equal to minimum of a2 of 1 comma 2 comma a2 of 1 comma 3 plus a2 of 3 comma 2. Basically I am calculating the distance through vertex 3. So a2 of 1 comma 2 is, if you see, it is 3, right? Minimum of 3 comma a2 of 1 comma 3 is 5. 5 plus 3 comma 2 is 8. So anyway this one is greater than this one, right? So I am keeping the old value itself, that is 3. If we follow the same process we get a3 values like this. Next we have to calculate the final a4 values. So a4 will represent the distance between two vertices through vertex 4. So the distance from 1 to 1 will be anyway 0, 2 to 2 will be 0, 3 to 3 will be 0, 4 to 4 will be 0, and 4th row, 4th column values will be same as the previous ones because it is already including that vertex. 6 3 1 0 2 5 7 0. Next we have to calculate for the remaining values. So I want to calculate a4 of 1 comma 2 will be minimum of, so basically I want to calculate this value, minimum of a3 of 1 comma 2 comma a3 of 1 comma 4 plus a3 of 4 comma 2. Minimum of a3 of 1 comma 2 is a3 of 1 comma 2 is 3, right? a3 of 1 comma 2 is 3 comma a3 of 1 comma 4 is 6 plus 4 comma 2. 4 comma 2 is 5. Anyway it is greater, so I am going to keep the old value, that is 3. Like this we have to calculate for the remaining vertices as well. Get the final a4 values as like this. So this a4 matrix will represent the shortest path between any pair of vertices in this given graph. So if I want to know the shortest path between 1 3, it is 5. If I want to know the shortest path between 3 2, it is 6. That's the shortest path that is available. Now let us write the generalized formula for the whatever the approach we have done till now. So basically I want to find the shortest path from I to j through vertex k, right? It will be equal to minimum of the path that exists at k minus 1 level, right? K minus 1 of I comma j comma a of k minus 1 of k minus 1 of I comma k plus a of k minus 1 k comma j. This is the formula we have used. So I to j has to loop through from 1 to n. So this statement I have to write from I equal to 0, I less than n, I plus plus, for j equal to 0, j less than n, j plus plus. For all the vertices we have to do, right? So this is the adjacency matrix at through vertex k, right? So at kth vertex, so like that I have to do from 0th vertex, 0th level to till the last vertex, right? So for that I am using another for loop for k equal to 0, k less than n, less than or equal to n, k plus plus. We have to loop the entire process. Since we are having 3 loops, the complexity of Floyd-Warshall algorithm is order of n cube. Thank you for listening my video.